Have you ever wanted to try to find the area of a triangle using a matrix? Is that possible? You betcha. If you want to find the area of a triangle, the old way that we used to do it in geometry is if you're given a right triangle with base and a height, the formula for the area was pretty easy, right? 1/2 base times the height. And that was great as long as the base and the height were perpendicular to each other. If they weren't, we had other methods, and we learned that in trigonometry. But for now, is there a way that we can figure this out using a matrix? And there is. It's probably one of the coolest shortcuts using determinants. Here's what we can do. What if I gave you, for example, a couple points here? I give you 0, 5, 4, 0, and one more point. How about just 0, 0? Those 3 points should form a triangle. Can you find the area of it? Well, by the methods that we know, we probably want to use this formula up here. But we do have to make sure that it's perpendicular. I think it is. So let me see. Let me just graph it really quick to see. If I have 0, 5 up here, and 4, 0 over here, and 0, 0 here, yep, that looks like that's going to make a right triangle. Let's figure out these lengths here. All right, from 0, 5 should be a length of 5 up here. 0, 0 to 4, 0 should be a length of 4 here. All right, shall we try it? A for area. Area equals 1/2. Well, the base of this triangle looks like 4, and the height looks like 5. That's 1/2 of 20, which is 10. All right, that sounds pretty good. But is there another way I can do that? The reason why I think about that is if I give you another example, and I give you strange points that are maybe not going to make a right triangle. I don't think those are going to make a right triangle. Even if they do, that's great, but it'd be great if we can find another way to find the area of this one. Well, let me go back to my first example and let me show you a cooler way to find the area of this triangle using a determinant of a matrix. All right, here's what I'm going to do. Watch this. Come on down here, my friends. I'm going to take a determinant here, and I'm going to take each of my points. Here's x and y. Next point, x and y. And last point, x and y. And I'm going to fill the last column with 1s. Why? Because that's part of the formula. We'll see in a second why that's the best. So again, I put the x's in the first column, I put the y's in the second column, and I filled the last column to make a full 3x3 matrix with 1s. And now I can take the determinant. All right, ready. Put all of the first column and the second column on the outside. And then we can do all our down lefts, down rights. All right, let's do down rights first. So my first down right is 0. That's nice. The next down right is 0 again. And the last down right, thank goodness for all these zeros. So all the down rights that way, and we subtract all the down lefts. All right, down left here should be, well, the first one is, again, 0. Let's do another down left, another 0, and how about the last one? Oh, finally, 5 times 4 times 1 is 20. All right, so far by this determinant, we have 0 minus 20, which is negative 20. Okay, well, I know back up here on top that the answer should be 10, so what could I do to my 20 to turn it into a 10? Well, one thing I know I can do is, if I want this area to be a positive number, an area has to be positive, I know I can multiply it by a negative number. And not even that. Even further, what if we multiply that also by a half? So I'll go a step further and say, let's take my negative 20 and multiply it by negative a half. And I get 10. And there's my area. All right, so let's put it all together. Here's your official formula. If you want to find the area of a triangle using the determinant of a matrix, it is the determinant of x1, y1 of your first point, x2, y2 of your second point, x3, y3 of your third point, and then we fill in the last column with ones, because that's what the formula says. And then we're going to multiply our determinant by 1/2, which is kind of easy to memorize, because remember we thought that the area of a triangle was 1/2 base times height. So if you remember that 1/2 here, that will help you remember that 1/2 there as well. But what if we do the determinant just like we did, and we happen to get a negative number? Well, we can't get a negative area, so what we do is we put a big plus or minus in the front, and we choose whichever one gives us a positive area at the end. For example, on the previous page, we got the determinant gave us a negative number. So in order to make it a positive area, we're going to multiply our answer, our determinant, by negative 1/2 instead of positive 1/2. And that's what gave us a positive 10. If our determinant is a positive number, well, then we can multiply by the positive 1/2 in the front. And that's how it works. Just set up a determinant with all 3 points here, ones in the last column, determinant, and then multiply in the front by either positive or negative 1/2. Shall we try those numbers that I gave, the next set? Let's do it. What did that look like on the previous page? I gave you these three right here. All right. We have 3, 5. We have negative 1, 4. And I think it was 6, 2. Now, I can try to graph that and see if it is a right triangle, so I can use my old formula, but by now, I'm pretty sure it's not. Let's just use the determinant formula with matrices and see if it works here. All right, area should be plus or minus 1/2 times the determinant of. And we can just go right in order, 0.1, 0.2, and 0.3. Ready? We have x, y, and x, y. Last column, do you remember? You got it. All right. Let me just work on the determinant first, and then I'll put the negative or positive 1/2 in a second. All right. The determinant of this would be all my down rights. I'm going to go a little bit faster now since we've been doing this for a little bit. We should have 12 plus 30 minus 2. Those are all my down rights. And I'm going to subtract all my down lefts. My down left should be 24 plus 6 minus 5. So just for my determinant, I should get 40 minus 25, which should equal 15. All right, that's just the determinant. That's not the entire area, but it's just the determinant. Okay, well, we can decide now when we're going to multiply by half. Should we multiply by the positive or by the negative? Well, if you look at our determinant is a positive number, so therefore we can just multiply by the positive 1/2. We don't have to multiply by the negative. All right, so I'll take my determinant and multiply by positive 1/2. Therefore, my area is positive 15 over 2, or 7.5. Could we have done that by graphing the points? I don't think so. I don't think this was a right triangle. But this is a really, really awesome shortcut. To find the area of any triangle in the world, whether it's a right triangle or not, you can always use determinant of a matrix. And it works out. What a great shortcut.